Okay, so let's now talk about solving nonlinear inequalities. Now these are still inequalities, but they're nonlinear, which means that something about them is not line-like. And what we have in those cases is certain things in the expressions that make it more complicated. Now things that make it a nonlinear expression are things like powers of x. So if you see something of the form x squared, x cubed, x to some power that's not 1, those are examples of nonlinear expressions. So for example, these look like parabolas or quadratics. These look like cubics. These look like general power functions. The other things that you can run into is x's in denominators. So something of the form 1 over x, or 1 over x squared minus 9. These are examples of things that don't look like lines. So if we were to graph these like y equals 1 over x, or y is equal to 1 over x squared minus 9, these would not look line-like at all. And the reason we identify these is that they require a very different solution method than what we saw with the linear inequalities. So let's go ahead and let's solve an example. Okay. Now, if we look at this for a minute, this is a nonlinear inequality, and the reason for that is we have this expression in the denominator that has a variable in it. So if I were to try to graph this, this wouldn't actually look like a line. It would look like something else. And the method that we're going to use is a little trickier and a little more complicated, because it's not easy to find values of x that satisfy this inequality, and the general method is not immediately obvious. So here's an algorithm that helps you figure out the method a little bit quicker. So step 1. We're going to move all terms to one side. We're going to combine terms, and then we're going to factor. Okay? So this is 3 smaller steps that combine to do one big thing. So let's do these algebraic steps first and see where this leads us. So let's combine these steps into one and see what happens. So we're going to first move all terms to one side. So if I notice I have an x plus 1 over x minus 4 on the left side, and I have a 2 on the right side, it seems simpler, so I'm going to move the 2 over. So that's going to give me x plus 1 over x minus 4 minus 2 is less than or equal to 0. So that's the first step. Now I've moved everything to the left side except for the 0, can't move that any further. Next, what we need to do is we need to combine the terms. So to combine the terms, we need to add these fractions, which means that we need to come up with a common denominator. Now this 2 has no denominator, which means that it has a denominator of 1, and this has a denominator of x minus 4, so that's what we're going to use. So we have x plus 1 over x minus 4 minus 2 times x minus 4 over x minus 4 is less than or equal to 0. And if we notice, this is the same thing in the numerator and the denominator. This is essentially multiplying by 1. So we haven't changed anything about the expression on the left. We're just simplifying its form. So we're going to take that negative 2 and we're going to distribute it over the entirety of the numerator on the right term. So I'm going to think about this as adding negative 2. And I get negative 2 times x, and then negative 2 times negative 4, that's positive 8 over x minus 4. And I'm still asking a question when this is less than or equal to 0. Now, I can go ahead and combine these terms. X minus 4 is the common denominator, so I'm going to have an x minus a 2x, so that's going to give me minus x, and a 1 plus an 8, that's going to give me a 9, and that'll give me an x minus 4 is the common denominator. And now I have converted this appropriately into the first 2 steps, and then I really don't need to factor because this is essentially factored. In some examples of the problems, you might have quadratics or polynomials in the numerator and denominator, and factoring is going to be a crucial step to understanding how to do those things. Now, the first question that you should ask yourself is, well, why did we bother with all that algebra? Well, what we've done is we've taken this expression here and we've turned it into a question about whether or not some other expression is positive or negative or 0. In this case, we're asking, when is this expression negative, that is less than 0, or equal to 0? And so these questions become easier because we don't necessarily need to know the exact values of all the factors. All we really need to know are the signs. Okay, so the first step simply converted our inequality into an equivalent inequality that asks whether or not an expression is positive or negative. The next step is to figure out where this expression can change sign. Now, if you go from a positive number to a negative number in a smooth fashion, you have to cross over 0. Or something funny has to happen somewhere in between. And those correspond to cases where some factor, whether it's the numerator or the denominator, are equal to 0. So step 2, we're going to find the zeros of all factors. Now, in this case, this is relatively straightforward. So the top factor, or the numerator, that's just negative x plus 9 is equal to 0. Well, when is that equal to 0? Well, I can add x to both sides, and I'll see that x needs to equal 9. Notice that I'm putting this special equals arrow. This is saying that this fact follows from the truth of this fact, okay? We're not saying that these are exactly equal. We're saying that they're logically imply one or the other. Now, if I look at the denominator, x minus 4, and set that equal to 0, I can add 4 to both sides, and I'll notice that x should equal 4. So these are the 2 points where we could switch sign, all right? So that leads us to step 3. We're going to evaluate the expression between and outside values found in step 2. Okay? So to do that, we'll just build a little table here. We're going to say what our x value is. We're going to ask what negative x plus 9 over x minus 4 is going to be. And really what we're interested in is the sign. So 4 and 9 are 2 values. I'm going to list these in order like so. And I need to find the values between these points and outside these points. So outside of 4 to the sort of left-hand side is going to be 0. Between 4 and 9, I'm going to evaluate at 5. And then some point beyond 9, well, we'll just choose 10. All right? So those are our choices for x. Now, if we plug in 0 for this, we get negative 0 plus 9. That'll give us 9. And then we get 0 minus 4 for the denominator. That's negative 4. Now, we don't need to simplify this fraction. All we need to do is notice that it is negative here. That's all we're worried about because we converted this question into a question of whether or not this expression was less than 0 or equal to 0. At 4, you'll notice that the denominator is 0. So if I were to plug this in, I'd have negative 4 plus 9. That's 5 over 0. And I'll notice that that is undefined. Okay? At x is equal to 5, I get negative 5 plus 9. That's going to give me a 4. And down below, I have 5 minus 4. That's 1. So that's 4 divided by 1. That's going to be positive. At 9, I'll notice I'll have negative 9 plus 9. That'll give me 0 divided by 5. 0 divided by 5 is just 0. And finally, the last point is 10. Negative 10 plus 1 is going to give me negative 1. And then 10 minus 4 is going to give me 6. And that's also going to be negative. So now what we've done is we've checked between 4 and 9, both to the left of 4, between 4 and 9, and to the right of 9, and figured out that it was negative. So now what we're going to do is we're going to convert that into a number line. Okay? Step 4, we're going to convert and I'm just going to plot the test points. So here's a 4. That's not 4. Here's a 4. Here's a 9, 10, 5, and 0 somewhere over here. So below the line, I've put an x. Okay, those are the x values, 0, 4, 5, 9, and 10. And above, I'm going to put the sign. Okay, so at 0, the sign is negative, so I'm going to put a little negative sign above it. Sorry. Above the 4, the expression is undefined, so I'm going to write that as UND. And that's just short for undefined, because if I keep writing it, I'll hit my step that I wrote right here. At 5, it's positive. At 9, it's 0. And at 10, it's negative. Now what this is telling us is that basically to the left of 4, this expression is negative, and the only time it can switch sign is once it hits an undefined point. So then after it crosses over whatever happens at x equal to 4, it's going to switch signs, and it's positive right here. So it's going to stay positive between 4 all the way up to 9. And then at 9, it's 0, so it's possibly going to cross over to the negative side, and in this case, it does. So then this is telling me that all through here, this is negative. Between 4 and 9, it's positive, and then to the right of 9, it is negative. So then once I have this number line, I can write down my solution. So by plotting this sign chart, we can simplify what we're looking for. If you notice, we took our original inequality, converted it into a question of when it's positive, negative, or 0, and then we plotted where it could be positive, negative, or 0. Now, if we look at this expression, this is asking for which values of x are less than 0, i.e. negative, or exactly equal to 0. Now, if I look at this, I have a negative over the 0, so that means that this expression is negative to the left of 4 all the way across here. So in fact, if I have x is less than 4, that's a set of solutions that basically covers all this section right here. Now notice it doesn't include 4, because if I tried to plug 4 into this expression, it wouldn't give me any number. You cannot divide by 0, it doesn't make sense, so it doesn't give us a solution. Now I notice to the right of 4, I have a positive sign. I am not looking for a situation where this expression is positive, so I'm not going to have anything between 4 all the way to 9. Now if I notice, if I plug in x is equal to 9, I'll get 0 in this expression, and I am curious when this is equal to 0. So the other point would be 9. And then if I look to the right of 9 at 10, it's negative, and since I am looking for negative numbers, this will include all those numbers as well. And this does include 9. So this would be one way to write down my solution. And that's a basic overview of what we'll call the test point, because you're testing at different points, or the sign chart, because we're making a chart of the different signs. So it's the test point method or the sign chart method.